Hello, Michael Hackney here, and we're in the laser corner of my workshop today. I am going to be cutting some Delrin, or actually the generic version of Delrin is called Acetal. It's 3/16 of an inch thick, and I'm going to be making a product that I sell to fly fishermen called a furling machine that allows them to take thread or fishing line and furl it like you do a rope to create a 3-strand or a 2-strand furl to use as a leader on a fly fishing rod, or to use as an actual fly line on what is called a tenkara rod. But that's really not the point of this video. This video is all about how to cut Delrin on a 100-watt CO2 laser. I spent a good 6 months trying a bunch of different techniques, learning about the material, and I wanted to pass those on to folks because Delrin is a fantastic engineering material and an engineering polymer. It has great lubricity, really good for wear for bearing surfaces, things like that, which is why I use it for these furling machine bodies. And just a pleasure to work with, especially to machine. But it's a real bear to work with on a laser for one really important reason, and that is the gaseous byproduct of cutting Delrin with a laser is formaldehyde. And formaldehyde is extremely toxic to people and animals in particular. Definitely not something you want to smell or breathe in. If you have even the slightest hint of formaldehyde fumes when you're cutting Delrin with a laser, stop immediately and figure out what your issues are with your ventilation and fix it. You do not want to be inhaling this stuff. It is carcinogenic, but it's also extremely toxic and will kill you. I don't know how long it would take inhaling it, but short enough that it's a problem. So as long as you've got really excellent ventilation on your machine, and I have my laser is actually vented out. I don't have the fan on right now, but it's vented all the way to the outside. It does pass through a 2-stage filter. One is just a HEPA filter for particulates. That's not a problem with lasering, but it just happens to be on there. But the other filter is a carbon filter, and it's about 6 inches of activated carbon with kind of a sinusoidal path that the gases have to go through. So it increases the resident time of the gases on the carbon to help absorb it. And I replace the stuff pretty religiously because it does absorb the formaldehyde and becomes inactive. So rather than take chances with that, carbon is literally dirt cheap in large quantities, so I just replace it. And then, of course, it's actually vented to the outside. I don't have any neighbors within hundreds of yards on either side. I make sure that the end of the ventilation pipe outside is clear, and that way I don't have any backups in the shop here. And I've found that it's been really safe. I've cut literally thousands of parts in Delrin of all different types, black and white, and never had a problem, never had even a slight odor. One little hint, after you're done cutting, don't rush over and open the lid of your laser to pull the parts out. Give it a good minute. Let that ventilation system extract all of those fumes and that formaldehyde out of your shop and out of the pipe, and leave your ventilation fan on for a couple of minutes just to make sure there's no residual formaldehyde in the tubing. It might find its way back into your shop. So with all of that said, let's walk through how I'm going to do this. I'm going to do it in real time. I haven't cut these parts in a couple of months. So I'm going to have to probably do a little bit of tuning on the laser on the cut profiles, and then we'll actually set it up and I'll show you some techniques that I use, not only for cutting Delrin, but for cutting all types of materials, all types of plastics, and also wood and other materials that you might find useful. My laser here is a G-Wiki 60 by 40, so it's 600 millimeters by, it's actually 450 millimeters in X the way I have it configured. It's 100-watt CO2. I've upgraded all the electronics and the tube in it to be high-end Chinese tubes and electronics. It's got the typical Rita controller, and it's been a beast of a machine for me. I actually got it specifically to cut Delrin, not knowing that no one really had discussed cutting Delrin much. I didn't find any YouTube videos. I didn't find much on the web and doing searches. And so I had to forge off on my own and sort this all out as I got familiar with lasing in general, and perils and good points of working with Delrin. I'd machined a lot of Delrin prior to doing the laser work, and I could always go back to machining this. But as you'll see, I actually do some engraving on these parts with my company logo and name, and it just is a much better finish overall. So that said, yeah, let's get started. You can probably see over here in the corner, and my camera work is going to be a little challenging today because I'm using my iPhone on a tripod and I can't really see what you guys are looking at. So I'm going to come back here, turn around here, pan over, zoom down and try to move the camera a little bit closer so you can see it. Actually, maybe I'll just take the camera out and we will just hand hold it. Okay, so here we are at my computer, and you'll notice that I'm using Lightburn. I have been a Lightburn user since it was in beta, and in fact, I reached out to the developer who was in secrecy mode and asked if there was anything I could do to help out in terms of developing software. And it turns out that there was, and I spent, I don't remember exactly, I think it was about 6 to 7 months working on Lightburn code in the early days. And in fact, these alignment buttons and the centering buttons and things like that, I designed the buttons and all the functionality underneath it. And I also did some of the vector points for the vector tool down here back in the good old days. And of course, I've kept up with my Lightburn ever since, and have spent hundreds and hundreds of hours using it and cutting my materials. So here is what we're going to be cutting. There's actually two of these parts, the top one and the bottom one, and they're upside down here. I'll talk about that in a second. I'm going to be cutting two of these parts make up one of my furling machines. So you can see here that I'll be making the bodies for 8 furling machines. You'll see that all of the layers are actually dim because I have the output set to not output at this point, except for the green layer CO3, which is set to output. And that's because you'll see up there, I've got the little green 10 millimeter square. And that is my practice cut that I use to fine tune my power and speeds when I first do a cut, especially after having it sit for a few months without having cut. Laser tubes do wear and slowly require more power to get the same level of cutting. The tube in this machine, I've been flabbergasted, is a little over 5 years old now. It has reduced about 15% in its power, and I've had to up the power to cuts to get the same quality of cut. But so far it's been humming along. When it gets to a level where I can't use it anymore, then of course I'll have to replace the tube. But for now, I just continue to use the tube. And I do a little practice cut at the beginning of each session, if you will, just to fine tune the cut parameters. And so let's go ahead and take a look at that layer, just so you can see what my settings look like. So really important things are that I learned is Delrin likes to be cut at reasonably low power, which means then you have to decrease the speed appropriately, otherwise you won't cut through. And again, this is 3/16 inch black Delrin. It doesn't have any glass fiber or carbon fiber in it. It's just pure Delrin. So I found that 35% power and 2 millimeters per second did exactly what I needed with one pass. And then I do have my kerf offset set. So when I do a part, I can measure it and it'll be spot on to what I want the final dimensions to be. And that's another really good reason for cutting a known little square or rectangle, in this case a 10 by 10 millimeter, that I can cut that out and I can measure it and make sure that my kerf offsets are proper too. Other than that, there's not a lot of other stuff going on here. I do use air assist, that's critical, and I'll talk about the setup and having airflow underneath the material here in just a minute, but that is really it. And it took me quite a bit of time to kind of go through and do these practice cuts and arrive at these settings, which will make a nice clean cut with just a minimal amount of cleanup required to scrape off the little bit of burr that is formed around the outside. So we're going to cancel this. I'm going to put guys back up on the tripod so we can come over here and look into the laser. This is a lot of fun. I have a lot more respect for the YouTubers out there that I follow and their camera work, especially when they're live in their shops or their garage. This takes a little bit of learning and practice, and slowly we'll get there. But for now, this is what we've got. Okay, so now you're looking down inside of my laser. This is the Delrin I'm going to be cutting. It's 12 by 12 inches, 3/16 of an inch thick. I'll open up the laser. Let's just make sure you can actually see what's going on here. And yes, you'll see I don't have a honeycomb. I have a sheet of steel that is folded along the front and back edge and made sure that this was extremely flat. I forget what the gauge of the steel is, but it's about 0.8 millimeters thick. So it's a nice stiff steel. When I bought this at one of my local sheet metal shops, I explained to them that I was going to use this on a surface for a laser, so it needed to be dead flat with no bends or curves in it. And they did a phenomenal job. I think at the time, probably about 8 or 9 years ago, it cost me about 75 bucks, and it was the best 75 bucks I've spent on this laser. The reason I do this is severalfold. One, honeycomb tends to collect the gases in those honeycombs. And you can make sure that your extraction fan is below the honeycomb so it can pull it out of there, but there's still some gases that are resident in the combs. And for things like acrylic and cutting plywood and other woods, a little bit of smoke doesn't hurt too bad. But in the case of Delrin, formaldehyde, you don't want it anywhere. So that's one reason. But there are other even more important reasons I don't use honeycomb and I use a steel surface. The first one is I use 5/16 inch diameter, 1 inch long neodymium magnets, and you'll see they just stick right to that surface. Yeah, you can see that. And I use these as standoffs. So I will position these standoffs and eyeball where they need to go to hold the material in place. Right now, this is just sitting on there and it could slide around, especially if you've got high accelerations on your laser. So there's a little bit of jerk on movements and not a good thing. So you want to hold the material down. So that's where I use these thinner, they're like 1/8 of an inch, same diameter. And I can just line up where the corner is and put one of those on top. And I'll come over here. These things stick together, so I use the edge of my laser here to help get them off, and you just kind of drop them right on. And now I've got the work piece held down. It's not going to go anywhere. And so a couple of advantages here. Firstly, this piece is pretty flat, so there's no bowing or warping in it, so I just could hold it down by the four corners. But if you were cutting very thin materials, and I have cut 32nd of an inch thick Delrin and wood and other materials and paper and card, you can use this magnet system to stretch the material, and you can even position more magnets with the body underneath to support the material, keep it from warping and bowing. So it makes it really nice to keep your materials flat. I usually do actually put one more of the standoffs along each edge. I don't need it. I just do it. If the piece is flat, and you can feel it by tapping on it, you won't feel any give. If that's the case, it's nice and flat. I don't put another little magnet on top of those. You could, you don't need to. Okay, so the other reason for doing it this way is now I've got lots of space, 1 inch of airspace, that my extraction system, and this actually is the slot that my extractor fan and ducting is connected to, can pool. And obviously we have to raise this up, so it'll be raised up closer to where that slot is, but it can pool all the air across this now flat, smooth metal surface underneath the Delrin and up and out and through the extractor very easily without getting hung up anywhere and creating fumes that might linger inside of the laser. So the combination of that smooth metal surface helps the flow, and then having 1 inch tall magnetic standoffs to position the workpiece up above that surface makes for a nice pathway for the fumes to extract. So what we're going to do now is position the laser somewhere over my workpiece, because we have to set our Z height, and we'll raise this up. And I've got this little focus gauge that I made, and 5 millimeters from the tip is my focal. And just a little. Okay, so that's just a little bit. Okay, so there we go, 5 millimeters. So now the focus distance is set, and I can position the laser up to a corner here. Now you may have noticed on my layout there, the 8 parts actually don't require the entire 12 by 12 inches. There's a bit of a strip along the top and even along the side. So I typically can just cut those little squares. Usually I only have to do it one time, and then I can move the laser down and everything's good to go. Before I forget, I'm going to turn on my extractor fan. And I'm just going to make sure it's not clogged. I don't know what the flow on that fan is, but it's a pretty high flow fan. I didn't chintz out on that because I knew I was going to be cutting materials like Delrin. So we're good to go here. Close the laser. And the only layer that I have active was that green layer with the 10 by 10 millimeter square on it. So I can just come over here and say start. If I can see my mouse. There we go. Oops. Oh, of course, Microsoft thought it was going to do an operating system update on me. Okay, let's see if you can see that. Yep. So you can see it's cutting. You can actually see the fumes running out the back and straight over to that slot. It's a little slow maybe if you're used to cutting acrylic and wood, but if you're cutting Delrin, this is the way you want to do it. So let's see if you can see the fumes. Oh, okay, so it's cut. Like I said, we're going to leave it sitting here for, probably a minute or so. I don't like to be too impatient. From this angle, you can actually, except for my lights, you can see where that dark line is. That's the slot for my air extractor system. And the table is just about an inch underneath that. So the bottom of the sheet of Delrin actually is aligned with the bottom of that slot. Ideally, the slot would be right in line with the steel platform, and I've thought about modifying my vent slot back there to accommodate that, but I haven't had the problem, so I'm not going to fix it. Okay, so there we go. Open it up. No fumes. That's the other thing. When you open it up, don't just stick your head in there. Kind of stand back for a second and waft some of the air over to you. And if you smell any formaldehyde, which you'll know if you smell it, it has a very acrid odor, immediately close the lid and let it vent for another minute or two. So now I'm just going to push that, and we see that we actually got a nice clean cut. Let's see if we can get a better view of it. Yeah, that'll do nicely. It's clear cut all the way through, and that's the bottom side of it. Minimal melting. That's one of the problems that you have with Delrin. The bottom side melts, and you can kind of see the glare there. That actually will polish off if it's not too bad. When I was first getting started and I was cutting at higher power and a little bit faster speed, you get a lot more of that, and it actually did mar the surface enough that it wouldn't polish out and ruin a lot of parts that way. So there we go. So now we can just come over here, and I'm going to reposition the laser to be right below that. And now I've got to come over to light burn, and we want to turn off output for that green layer, and we want to turn on output for all the other layers. I do still leave the green layer there because you see it actually puts the origin spot right at the corner of that green. And so that way I've got this lined up, and I know that it's going to shift everything over to the right by 10 millimeters, and I should be good to go. Let's just talk through this cut a little bit. The blue layer that gets cut first is my logo, which is a jumping trout. It's upside down here, and then my name and my town, Groton, Massachusetts. So people that purchase my machines know, that they're buying an authentic furling machine. They're upside down for a reason, and that is the airflow is going to go from the bottom to the top in this drawing. So the bottom here in my laser is the front of the laser, and the back is where the vent is. And by doing the airflow that direction, because these are not through cuts, these are engraving cuts, the smoke doesn't have anywhere to go except to flow over the top of the part. And I found that by extracting it this way, I get minimal residue on the rest of the part and in the logo itself. And then so it just makes it for a little bit cleaner engraving when it's all done. So first it's going to do the engraving pass, and these are actually vectors, so it is truly engraving. And then the orange layer are the through holes, and you'll see that there are 4 1/4-inch holes here, and those are where shafts for the furling machine go, but they're 1/4-inch through holes. And then I've got 4 little holes in the corner. Those are for 440 machine screws that actually are used to hold the front to the back of the part. And similarly, the back part of it has the same 4 1/4-inch holes. It has the same 4 440 holes, and then it has 2 larger holes here, which are used to mount the furling machine to the end of a table or a board with some wood screws. So that's really all there is to it. Now what I like to do is come over, and I do a frame, and we just want to make sure that the laser is going to stay in the body of the material. And we see that it is. and we're good to go. So we are all set to start the cut. Everything's okay. Ventilation's fine. So I'm going to click start, and this is going to take, I think I put a comment in the file I saw when I opened it, 30 minutes. So I'm not going to bore you by watching it for 30 minutes, but we'll just watch a little bit. Firstly, you can start to see the engraving here. Let's see if I can actually zoom in on it. Yeah. Okay, so okay. So there you can see my trout upside down and my maker mark and location. You see a little bit of the white fumes. That will actually just wash off very easily with a little bit of isopropyl alcohol. Okay, so let's stop this. When we get ready to start actual cutting, I will come back and we'll see some of those holes get cut. And then finally we'll see perimeter pass, which was the black layer I didn't talk about on Lightburn. Okay, we're back. We're doing some cutting now. A couple of things. Firstly, sorry about my laser glass here. It's pretty scratched up and old. I must have been mucking around with cut order because it's not cutting the way I normally cut these parts. And I don't remember exactly what I did or why. Well, I know what I did, but I don't know why. In the old days, I used to do all of the engravings first for all 8 machines. Then I would do all of the through holes first for all 8 machines. And then I would do the profile cut for all 8 machines. I don't use tabs. I actually started making these parts before there were tabs in Lightburn. And even with the tabs, I do this little corner trick at the top side. So you see the bottom of the part here has curved corners. The top side is straight. Right in each of those corners, I leave a little bit of material as a tab on the corner. And that way, when I pop the part out of the sheet, I can easily sand that off and it doesn't leave any marks from tabs anywhere on the visible parts of the machine. It's just something I started doing and I never changed it. So what we're actually seeing is now it's kind of doing a mishmash of those engraving passes with the holes, the 3 holes, and the bodies. In fact, it's cutting the bodies in several parts. So that top the top horizontal line is being cut, and then the actual profile of the body, which it's doing now, is being cut. Just kind of a little bit of an anomaly. It doesn't really make any difference. Maybe I found that it decreased the cut time a bit by doing it this way. I'll have to go back and look at my notes. I just don't remember. So that's it. I don't think there's any more reason to show all of these getting cut. Close the video for now, and we'll come back when this is all done, and we'll take a look at the finished parts and then cleaning them up just so you get an idea of what this is all about. Okay, so it just finished up doing all of the cutting. Just wanted to start this little recording so I could get the timestamp to see how much time it actually took to do. I'm going to let this sit here and evacuate the fumes for a couple of minutes, especially after a long run like this, no sense in hurrying it. While we're looking at this, a couple of things I'll point out. One, you notice most of the parts, well, the main body of the parts are going to stay in the sheet because of the little corner tabby things that I mentioned earlier. But you notice that most of the through holes have not fallen out. There's one right there that you can see that actually has come out, and one right there that has come out. And actually that is fine. I found that if you have enough power that cuts through so much that these little hole features can actually pop out, you've put too much power in, and the back side of the part is going to be sort of molten and fused with a little bit of a ridge. So I found that getting a perfect cut, that the friction just kind of holds the piece in the hole, but yet I know that the cut was a through cut because I can see the fumes extracting through the bottom and out the back of the part. So that's an indication that the cut goes all the way through. By doing it that way, I will have to come back and poke out each of those little parts that are in the holes, but it will leave a much nicer finish on the back that won't require any additional work before assembling the machines. So that's the reason why I do that. What we're going to do next is, once this is evacuated, is to go over and pull the part out and clean off all the white residue with some isopropyl alcohol. And then off camera, probably I will start to poke out all those little holes and get the parts ready to assemble. But that's the main gist of this video, was just to talk about how to safely laser cut Delrin, that it can be done and that you can actually get some really quality parts out of it. I'll probably maybe do a little video on this part too. Along with these furling machines are these little gears, and there are 4 of these little gears in each of the machines. These are cut out of 1/8 inch white Delrin. Hopefully you can see that. Let's see if we get that focused. Let's see, put it here. Yeah, there we go. That's the back side. You can see just a little bit of melting there. And then the front side. So these are ready to go. And again, you can get some pretty nice detail on parts, and laser cut Delrin gears are a great application for using Delrin. So this is the project notes that I put into Lightburn from past runs. You can see it said 32 minutes and 30 seconds is what it took to engrave and cut all of these parts. When I went back and looked at the start time of the video and the end time of videos, it was right at 32 minutes and I think 25 seconds or something like that. So pretty much right on par with that. So 32 minutes and a half or so to cut all of those parts. Not bad. Okay, and one more thing. I have removed my parts and did not smell any formaldehyde fumes at all, so that's great. I did want to point out, you can see the little black parts down there from where the center of the holes popped out. Make sure you clean those out of your laser and dispose of them, because if you leave them there and put another sheet on top and start to cut it, they can and will catch on fire. And Delrin fires are really difficult. It burns almost colorless, so you can barely tell that it's on fire. It burns really, really hot, and it burns really, really fast. So highly recommend having fire extinguisher near your laser. You should do that as a matter of practice anyway, but when you're cutting Delrin, be double sure that you have it and know how to use it. And make sure you clean up all of the little parts like that before you start cutting another sheet, because they are a fire hazard. This is probably going to be a bit of a funky perspective because of the angle, but here I have my isopropyl alcohol. I like to get the good stuff, 99%, and just put a little bit on a rag. And you can see all it takes is a little wipe, and we get all of that residue right off of there. Maybe flip it over and see if there's any residue. Just a bit. You can see where the fumes were extracted out the back, and we'll poke those out. Oops. Okay, that's good. That's really all it takes. And then I just use an old screwdriver, and this is the fun part. Just go through and just poke, poke, poke. You can hear them just snap right out, little guys. Oops, kind of a satisfying snap. There we go. And then you saw that whole part just pop out. Let's get all these guys out of there. There you can see the finished part. You can see the little ears here where I have my tabs, and those just literally break off, and then a little bit of sanding and it's done. I hope you can see the edges. They're nice, clean cut edges, and they are perfectly square to the part, so there's not any angle on them, even though this is 3/16 of an inch thick material. A little bit of cleanup on these parts and they're good to go. You can see the back. There is virtually no surface melting or puddling around the holes at all. That's because we use just the right amount of power to get the parts cut, so there's not that melting on the back side of the Delrin. So I've got another 15 parts to punch the holes out of, and then a little bit of cleanup on those corners, and these are ready to start to assemble.
Let's go through a checklist on how to safely cut Delrin and Acetal. For settings, I target a slow speed of 2 millimeters per second, and then I adjust the laser power to just barely cut through the part. If you put too much power into the cut, you'll actually melt the back side of the Delrin, and often it'll start a flame back there too. And that's very, very dangerous, especially if you're not carefully watching. In the early days when I was first learning how to do this, I was putting way too much power in, and the Delrin would just burn on the back side. And as I described, formaldehyde gas is extremely flammable. So you just want to be very careful with cutting Delrin and not using any more power than you need. That really was the critical aha moment that I discovered when I was doing all my research on how to cut Delrin material. The second point is, and never forget this, Delrin gives off toxic and carcinogenic formaldehyde gas. So it is imperative that you have excellent ventilation for your laser system. If the gaskets around your laser box are failing or leaking, make sure you replace all of those or install new gaskets so there's no opportunity for fumes to come out of your laser. And then when you're finished cutting, wait at least 1 minute before opening your laser. And when you do open it, as I mentioned in the video, don't just stick your head in and reach for the part. Kind of stand back, open the laser door slowly, kind of waft the air from inside the laser towards you. And if you get any hint of that acrid formaldehyde smell, immediately close the door of the laser and let it ventilate for another minute or two. At the end of a long run, like the one I did in the video, I typically let it ventilate for at least 2 minutes just to make sure all the formaldehyde gas and fumes are out of the laser and sucked out of all of my piping in my ventilation system and out through the carbon filter cartridge and outside. It just is something that I do kind of routinely, and consequently, I never smell even a trace of formaldehyde. So be very, very careful with that. And then the other thing, keep in mind, is formaldehyde and Delrin are extremely flammable. And when it burns, it's colorless. So you can very quickly start a fire if you're using too much power or not paying attention. And once that fire gets going, you'll see the Delrin itself melt, but you won't see the flame. And so make sure you have your fire extinguisher handy and make sure you know how to use it. So just be very careful and make sure that you're not leaving your laser unattended. And especially when you're first getting started, you want to keep an eagle eye on everything. So that's pretty much it as far as a checklist for effectively and safely cutting Delrin. And then finally, just to wrap it up, is a photograph of the front and back side of the parts that I just cut. And you can see my laser engraving here of my Trout logo and my maker stamp down here. This is the front part of the part, and this is the back part of the part. And this is what the finished furling machine looks like when the thing is all assembled. If you're actually interested in furling machines and you'd like me to do a video on how they're used, leave a comment down below. And please subscribe to my channel. I'm going to be doing a lot of material over the next few months on lasers, on CNC machining, on CNC routing, and on 3D printing. There's a lot of similarity between these different technologies, but there's a lot of differences too. I have several decades of experience in working with all of them, and I'm looking forward to sharing my knowledge and some of my ideas with the community, and hopefully even learning a few things myself from feedback that I hear in my comments. So please subscribe. Thank you.